Hey everyone, welcome back to my channel. In today's video, we'll be talking about threats in operating system. So without wasting any time, let's get started. Let's understand what is threats in computer science. Threats are a crucial concept in computer science and software development. They enable concurrent execution of tasks and are fundamental to smoothen the functioning of modern computer systems. Now let's explore about threats more. Threats and multi-threading. While discussing about the threats, the concept multi-threading naturally arises. Multi-threading refers to the ability of a CPU to provide concurrent execution of multiple processes or threads. This facilitates the implementation of multitask concurrently, thus enhancing system performance. There are different types of relationship in multi-threading, such as many-to-many, one-to-many, and one-to-one. In many-to-many, the multiple user level threads are multiplexed onto a smaller or equal number of kernel level threads, as you can see in this diagram. In one-to-many, a single user level thread maps to multiple kernel level threads. In one-to-one, each user level thread is mapped to one kernel level thread. You can refer to the diagrams. Moving on to the next slide, which is benefits of threads. Let's understand the benefits of thread, which are of four different type. Concurrent execution. Threads enable concurrent execution of tasks, leading to improved system performance and responsiveness. Resource sharing, where the thread facilitates sharing of resources such as memory and data, aiding in efficient utilization of system resource. Third, the responsiveness that contribute to responsive and interactive software system, which enhances user experience. And fourth one is modularity, where the threads allow the modular and efficient code design, promoting scalability and maintainability. Types of threading. There are two types of threads, which is user space and kernel space. User level thread, these managed by user level thread library without kernel support, providing the flexibility but lacking in system level control. Meanwhile, the kernel level thread is managed by kernel, and these threads offer efficient system level control but may be less flexible at user level. Now let's see the relationship between threads and processes. Threads are resources directly, meanwhile the process require inter-process communication mechanism. Threads within the same process share the same memory space, making them lightweight and efficient compared to the process. Shared resources. Threads share resources directly within the need for complex communication mechanism. Memory spaces. Threads within the same process share the same memory space, making them efficient, and they are lightweight. Threads are lightweight and have faster creation, termination, context switching of time. The role of threads in parallel computing. Threads are pivotal in realm of parallel computing, enabling the concurrent execution of tasks across multiple processor or cores. This facilitates the efficient utilization of computer resources and accelerates the completion of complex computations. There are three main roles of these threads in parallel computing, which is efficient utilization, that enables the efficient utilization of computing resources for parallel processing. Then the multi-core support, which is threads harness the power of multi-core processor for parallel execution of tasks. Next one is accelerated computing. Threads contribute to accelerate the computation by leveraging Prism. Let's see about the thread synchronization and coordination. Thread synchronization and coordination are critical for managing concurrent access to shared resources. Techniques such as logs, semaphores, monitor, play monitors, which play a vital role in synchronizing the access to critical section of code and achieving thread coordination. Let's see about these three. Locks are used to ensure exclusive access to a shared memory resource by a single thread at a time. Meanwhile, in Semaphore, which facilitates thread synchronization and implement critical section mechanism. Monitor Monitor provides a high-level synchronization mechanism for managing concurrent access to shared resources. Now let's talk about the thread safety and concurrent programming. Ensuring that thread safety is very vital in concurrent programming to prevent data corruption, and the techniques such as atomic operation, exclusion, and proper memory management play a vital role in achieving this thread safety. Let's talk about each one of them. Atomic operations. Atomic operation ensure that specific operations are executed as a single indivisible unit. The mutual exclusion, which is a technique such as locks and semaphores, are employed to achieve mutual exclusion and prevent race condition. Memory management, uh, which is crucial to prevent data inconsistency and ensure thread safety. Let's see the challenges faced in multi-threading programming. Multi-threading programming poses various challenges such as race condition, deadlock, and resource contain and the deadlocks. The effective management of these challenges require a deep understanding of multi-threading principle and best practices. Let's talk about each of this problem. First one is the race condition. Race conditions arises when multi-threads access shared data concurrently, leading to unpredictable behavior. Now, the deadlock occur when two or more threads are unable to process because each is waiting for other releases a resource. Then the third one is resource contention. Resource contention results from the thread competing for access to shared resources, potentially leading to performance degradation. Now, let's talk about the best practices in thread management. The implementation of these practices is very crucial for the efficient and reliable operation of the software system. Techniques such as thread pooling, proper exception handling, and efficient tasks play a vital role in the achievement of optimal thread management. Let's talk about thread pooling. The thread pooling facilitates the reuse of threads, enhancing the performance and resource utilization. The exception handling is essential to ensure the stability and resilience of multi-thread application. The last one is task scheduling. Efficient task scheduling ensures the optimal utilization of computing resources and load balancing among threads. And that's all for this video. Thank you for watching. Please like, share, and subscribe.